I've seen me just press record. That's just for people who aren't able to make it, and if you want to catch up. So you've got the handout. I'm just going to follow that basically. So you've got calculator at the ready. The idea is that you follow the same button presses that I do. So it's kind of a muscle memory. I'll pause and wait for people to sit down. So feel free to stop me anytime with questions, but let's get into the first one first, which is how to do inverse functions. What I strongly suggest for this is for you to define this function. So let's get in there and do an ln x to the power of 4. So let's define that. And my purpose for defining it is to sketch its graph. Let's sketch the graph. Click on the graph button. I've already got something there, so I'll just clear all that. Usually we want to initialize or a quick standard and basically just drag f of x into there. See what happens. We get this. What I wanted to point out with this graph was, I'm going to zoom out a little bit. And a small, actually I won't zoom out, I'll zoom in and just show you that sometimes with exponentials you might get, oh I don't see it there, but you might not see a vertical line on your CAS calculator. That doesn't mean it stops there. I'll show you another example a little bit later on. We need to be careful with vertical lines. Casio won't draw exactly vertical lines. Maybe if I change the scale there.
No, change the x to 4 to
yeah.
-1 or something.
Yeah.
So 4 minus 1. Yeah.
Change it to -1, you reckon?
No. The power of 4 is still there. But subtract 1 from the whole quartic. Just the quartic.
Oh yeah, like this. You reckon?
Like that.
We'll see what happens.
Yeah, it's not far enough. Maybe 6 or something.
I'll show you another example where what I want to stress is that a vertical line won't necessarily be drawn by your calculator. That doesn't mean it's not there, and so to explore you might need to use your zoom in button, or something that I sometimes use is the zoom box. So I can zoom into something and I can see that it isn't actually vertical, or it is. I'm going to go back and do all that again, because that wasn't really the question. Okay, we sketched this graph. What's the question? The question is, there's a function, it will have an inverse function if. What's going to happen with this inverse function? Well, it's only going to have an inverse function if it's 1 to 1. And what's the smallest? Well, what's the value of a that will be? So the best way that we can approach that, I think, is to sketch a graph. And we have sketched the graph there, as you can see. Sorry, I just need to look something up. We've sketched the graph, you can see there, and you can see, if I can use my mouse, that we can either use the left-hand side there to be 1 to 1, or the right-hand side, and you can see that there's an asymptote there at a, that x equals 0, and so we're either going to go less than 0 or more than 0, but it says a to infinity, so obviously it's going to be a to infinity. What's the trick here? the trick for this particular question that I want to highlight for you today is this. To answer this question, we use this. Sketch a graph. And you do that on your calculator and you can see straight away that it's D. Happy with that? First tip for your SAC. Often the answer is sketching a graph. Let's do multiple choice question 5. You'll find that this too uses that skill, sketch a graph, except that in this case we have these annoying little A's and B's. We've got an A here and we've got a B there. It's true that if you have A's and B's, you can use the slider. But you can also choose values. So I'm going to clear this just for the purposes of keeping things neat. I'm going to clear that as well. Okay, clear screen, and I'm going to define again a function, but this time I'm going to define the function sine x plus cos x. Here we go. Sine of x, that shouldn't be capital, plus cos of x. And you may have noticed already that I haven't put A's and B's in there. And what I've done, for no particular reason, just because it's easy, is to choose A equals 1 and B equals 1. The purpose of that is just to see what the graph looks like. Maybe I don't need to define it in this case, and I'll just drag it in there. And I can see that this is the graph shape. It's from this that I can now draw some conclusions. If that's sine x plus cos x, where A equals 1 and B equals 1, at least I can see the shape. What this is asking me is, when is the graph reflected about the y-axis and equal? You can see from this graph straight away that that's not going to happen if A and B are equal to each other. Are equal to 1. I'll sketch a couple of other graphs. I don't need my calculator to sketch these. There's sine and there's cos. If I add them together, I get what's on the calculator. But I can see that if I reflect this graph around the y equals x graph, I'll use a different colour, I will get this. That's not going to be the same. Yeah, it's not the same graph. Whereas if I reflect cos around the y-axis, it is the same graph. I can see from that immediately that the answer to this is going to be when A equals 0. When A equals 0, my function becomes just cos x. In fact, to be a bit more accurate, it becomes cos, or b cos x. And for that function, this is true. If I make b 0, I get sine, and that's not going to be true. If I do a plus b, maybe I should try this. If I make a plus b equals 0, or in other words, make a equal to negative b, I could test it here. That would look like this. Does that work? I'm taking the slow way around just to show you, no. If I make a minus b equals 0, that will be sine plus cos, and that won't work either. So what's the answer? A equals 0. What's the trick? Sketch a graph. So my first tip to you for both multiple choice and analysis is often the answer to a question will be accessible to you once you sketch a graph. I wonder if that's true for the next one. We're doing 2022. Task 2. And we're doing multiple choice question 4. So I'm just going to clear this. And you should practice with me in defining this function. Get the keyboard up, and I'm going to define this function e to the power of x minus b. The b, if it's in an equation and it's a parameter, should be from the variable keyboard, not ABC. Somebody told me today, oh, it doesn't make any difference. Yes, it does. So there's my function. I'm going to define it. Just good practice to define. Maybe I don't need to define it, but it's just a habit I get into, and I think it's worthwhile, particularly for analysis questions. In this case, I want to do the same as that very first question. For what value of b will I have an inverse function? And I want to sketch this graph. My first tip to you earlier was just to put a number in there. I'm going to suggest a different method here. You can put in a number, like 1, 2, 3, and sketch the graph. But I'm going to use the slider in this case. It's a good opportunity for us to learn how to use the slider. I'm defining it here because this is just normal practice for me. Whether I'm doing multiple choice or analysis question, I tend to define the function in case I need to access it later. In this case, I really only need this part. I'm going to copy that, and I'm going to paste it into my y1, y2. I'll just get rid of that. That was from something else. So I'll repeat that. I'm basically cutting and pasting this section of the equation, or I could just drag it. Okay, I've got that in there. In order to make the slider work, I need to tick that and then tap on the icon second from the left, and I'll get this function. And I'll get my slider. And I can slide along to see what effect that b has on the shape of the graph. And I think you can see immediately that what's happening is it's just shifting left and right. And what we need to see here is the turning point. And you can do some algebra if you want here, but I wonder if you can see what's going on when I have a b of 4, where the turning point is, b of 5. You can see straight away that the x value of the turning point is b. I can see that anyway, I think, if I understand transformations. I'm basically shifting b left or right. So I need a domain which either goes from negative infinity to b. So my possible solutions are, let me write that again, negative infinity to b, or b to infinity. And I haven't looked at the distractors yet because I won't be distracted. Now I'll look, and I can see that C is the answer. What's the trick? Sketch a graph. In this case, I've used the slider. Can I point out an important part about the slider now? Now that I've done this, my calculator thinks that b equals 2. So, if I get out of all of that, go back to my main menu, I'll see that in my variable manager, I have b as a value, and I need to delete that. So now b is already a variable again.
Can I just point out, before your SAC, you should be clearing your variable manager of any variables you may have had from previous calculations. That's quite important because if b was equal to 2 and you were using b in next Tuesday's SAC, that sure that you are clearing your variable manager and making sure that you haven't got things in there that shouldn't be there.
Students listening to this on the video, Mrs. Schaffner just said, make sure before your SAC you clear all your variables from previous work. And there was a question. Ava, was that you with your hand up? Or was it somebody next to you? No. Yeah, go.
How do I know that the B isn't negative?
How do you know the B is not negative?
Yeah.
It can be. I'll go back to my slider. See, I can make B negative. Yeah? See?
Yeah.
And it's still, in this case, B is -3. In this case, if I'm going to draw it without using B's, my domain for an inverse would be -3 to infinity. So it can be negative, yeah? Does that answer your question?
Yeah, so how come it could be E?
Oh, because that's negative B.
Oh, okay.
So if it was, say, like I've got -3 now, negative of negative would become a positive. That's a trick question.
Yeah, cool. Thanks.
Yeah, good spotting, actually. Yeah, so for those of you listening to the video, the question was, why can't it be -B? And it's because if you, say, used -3 here for an example, it would be the wrong answer. Okay, let's have a go at, I think for this question, parts 1 and 2 are not too difficult. What I wanted to do was to get into part B, the graph sketching. And I think this question is the one where that vertical line will be an issue. So I'm just going to find the answer to part 2, and then we'll do the graph sketching from there. I think it was -4. Let me just find my notes. Nearly there. That's the one. Okay. So the rule was this. So let's put that into our calculator. Yeah? Okay, instead of f of x, I want ln, ln, another bracket, x minus 1 squared minus 4. So we want to define that, and we want to sketch the graph. It says, sketch the graph when m equals 4, label the coordinates of axis intercepts and equations of any asymptotes. So let's just define that and graph it and see what happens. And there we go. There's an example of what looks like this graph ending there where my mouse is circling. It's not ending there at all. I'm just going to zoom box right in there to show you. If I zoom box into there, you can see that that graph actually extends. We have to be careful with that. So it would be incorrect, and I do think we saw this. I'm just going to sketch this graph roughly. I think we saw this when we saw some of the SACs. We saw students doing this. That's not correct, so be careful. Okay, let me just rub that out. What's in fact happening, and it's quite difficult to see on CAS here, is that there's an asymptote at 3 and an asymptote at -1. and it's going all the way down. We need to be cognizant of that when we're using our calculators. That in fact, we've got some asymptotes there. I'm going to work out some values for you. First, I'm going to solve for 0. We okay with that? Solving for 0, pretty simple. If you wanted to, you could find the decimal first, so you could get some sense of scale. So we know that it looks like this. Something exciting is happening out there. But we want exact values. Square root of 5 plus 1, 0. Negative square root of 5 plus 1, 0. I love this acronym. Read the question, answer the question. By saying that, what I mean is go back to the question and check that you've answered it. Label the coordinates of the axis intercepts. Yep, I've done that. And the equations of any asymptotes. Yep, I've done that. I don't need to do any less or any more. 3 marks. Next. Oh, I love this question. Task 2, 2023. As usual, please put that equation into your calculator. I'm going to leave the f of x there because I'm going to define it. Keyboard. I'm going to show you how simple it is to do general equations with CAS. So, shift divide for my fraction, pi over 6, pi over 6, bracket minus root 3. Oh, what have I done? I haven't defined it. Okay, I think that looks right. Define it. And I want to solve for 0. First thing I need to check is my rad degree grey. We want to be in radians. And we want to solve this equation. F of x equals 0. Do not be frightened when you get this result. You're getting a constant n1. I can read off that and basically say that this is my result. X equals 2 pi. That constant n will be an n. In our case, the question's got a k, so I'm going to use a k instead. So it's really just this. So I'll just circle this part of the calculator equals k. It just represents a pronumeral, a parameter. So you needn't be frightened about it at all. In fact, it gives you the answer. 2 pi k over 3 plus pi over 18. So that's the answer. If you ever need to use that for an analysis question, there you go. We've done the general equation. Of course, with multiple choice, we don't want it to be that easy. So none of these look like this, and you've got to do a bit of fraction work. And so it's all over 18, which means a 3 pi there and a 12 pi k there, over 18 there, which is 12 pi k plus pi. Take out a common factor of pi. And I think this will be the solution. I'll just check. Do any of those look like that? Yes, they do. It's E. I'll try that again. Circle, beautiful. Yeah? So do not be frightened by solving trig equations in the general sense. Okay, next question. Do you like the last one? That one? Nah. Hang on. What do I want to talk about? Okay. I'm just going to add that if you do have a domain, you would do this. Now, this isn't in the question, but if you do have a domain, goalpost, let's say it's between 0 and 2 pi. I'm making that up. I've got no idea whether that would work. If you did have a domain, there you go. Put the domain in and you'll get all the solutions. Let's make it less of a domain. You know, if you did have a domain of 0 to pi, it will give you all the solutions. If you don't have a domain, it will give you the general solution. Okay, let's go to one more question. I suppose I did want to talk about composite functions and how to do that. Maybe I'll skip that and just give you a bit of advice, which is sketch a graph. Same with this one, same with that one. So we're going to the last one apparently. Put in the function. Define it. Okay, so I have defined this function and I'm trying to work out the values of A and B so that this function f of x looks like this function g of x. There's a couple of ways you can go about this. One of them is to use intuition. I can see that this bit here is, well, that bit there actually, is kind of reflected there. But the maximums are not changed. So I'm thinking there might be a reflection around the y-axis, which would mean that B would be negative. Sorry, I'll say that again. Yeah, B would be negative. I'm also seeing maybe a reflection around the x-axis, which would mean that A is negative. I also see that the period is changed a little bit. I'll show you what I mean. If I draw a line across here and choose these 2 points, I can see that my period there is 2 pi. But I can see that the other function, let's go between two values where they like between here and here, or this one. Yep, that sounds good. What's this period? Between there and there. There and there. It's about twice that. So my intuition tells me this. If I'm dilating by a factor of 2, this needs to be x over 2. What's the clue? Sketching graphs. There's f of x, and this is what I assume is correct. Does it match? It does. So my 2 marks will be A equals -1, B equals -1/2. Sometimes you might not get this right. You might have chosen that. Sketch it. Nah, that's not right. Yep.
Can we talk a little bit about?
No, we can't. We can't.
I'll talk to my class.
I'm afraid we have to end there. But there's more. The solutions to this will be posted in the same place as the blank tasks in the Google Drive. Say that again.
Yes.
What?
Where will they be posted?
In the Google Drive.